Hey, geometry friends, we're in chapter 12 and we're looking at representations of three-dimensional figures. So the first thing that we need to talk about is what is an isometric view and what's a cross-sectional view. And cross-sectional view, you guys are kind of used to. I'm going to start with that definition first. When you think about a cross-sectional view, I want you to consider when we used to talk about like having a figure, like a sphere, and we would talk about a plane coming in and intersecting that sphere in kind of a circle. That's a little bit of a cross-sectional view. So it's the ideas that it is exactly what a cross-section is. If you take a slice of something or the intersection of a plane with a figure, what figure do you make? That will be the cross-section. What is the intersection like? So that's what a cross-sectional view is. And I'm going to take my terrible drawing off the screen. And then an isometric view is best described by this picture. So an isometric view, this is more of a front view. Isometric view is when you have kind of a corner point view, when you're looking at a particular three-dimensional figure from a corner point. We're going to practice drawing that today. So in example one, we're asked to use dimensions of a solid to sketch the solid. And so this is isometric dot paper. You can pull some of it up on the web. If you were like really destined to have some, that's cool. Okay, so use the isometric dot paper to sketch a triangular prism 3 units high with two sides of the base that are 2 units long and 4 units long. So the first thing we should do is kind of remember what a triangular prism is. It's going to be some situation where we have a triangle, and it's almost like sometimes I think about true triangles attached by walls. Kind of like you've got like a triangle on one side and triangle over the other, and rectangular faces that will connect the whole thing, right? If you can kind of imagine that. Hopefully our drawing will look better if we use this fancy isometric paper. All right, so let's go back. We know that we have the base is 2 units long, so we can start with 2 units like that, and then 4 units long, and then we'll connect that. And remember, both of the bases are going to be the same, so we also have the fact that the height is 3 units. So 1, 2, 3, and then we get kind of a similar figure down here, or really a congruent figure, right? And this is the best I'm going to do, my friends. So this next example is a bit of a trip for me because I don't know if I see this in the same way that our textbook authors do, and they don't really give us a guide in terms of answering the question. So let's see if we can try to do it. We're going to try to use this isometric dot paper to draw this orthographic drawing. So what this is like if you had like blocks set up in a particular three-dimensional form and you looked at it down from the top, you'd see this view. If you looked at it from the left side and the right side, you'd see these two views. And if you looked at it directly from the front, you'd see this view. Take a second to draw that in for yourself for a minute. Now, these dark lines indicate different height ranges. So like this dark line here, darker, more bold than this one, is indicating that one side is higher than the other. And then same thing here, one side is coming out more than the other. And then I can't even tell if this is dark or not. Anyway, I don't know, this is pretty tricky for me. I know what the answer is, so part of it is like, like as a teacher, I'm gonna like have the answer and say, okay, here's the way you walk to it. Yeah, I ain't got that right now. I'm just being honest with you. So I'm gonna do what I did and go over to the answer and look at it. So here's what it looks like. Did you guys get that from this? You have to let me know because I'm not getting that at all. This is not a major portion of what I'm expecting you to be able to do, but I'm looking at it. I'm like, I get it. I'm just gonna leave this here and not actually try to draw it because I mean I can, but I'm just kind of cheating. So here's the base view. I mean the top view. When you look at the top view, you see that you would see four squares all neatly put together if you were coming in from the top. If you were coming in from the front, I guess if this is the front, that's what you would see, that L view. And then if you're looking on the right over here, you'd realize that that's why this is a little bit indented. You realize, or bold, you realize that there's difference of height here. And then on this back side, you'd realize that there's that it's all flat. And so that's the left view. Guys, I'm just going to be honest with you. I can't see it. I'm not pressed with this section, but I at least want to expose it to you. I really can't see how to draw that. I can draw it, but it was just cheating. So you guys let me know if there's a way that you process. Like, I legitimately want to hear. Is there a way that you process through this that you could have without seeing this drawn, with just seeing this drawn this? I don't know. All right. Letting you know I'm weak. All right, let's look at the last example, which is just about identifying cross sections. And so in this situation, pyramids, scientists are able to use computers to study cross sections of ancient artifacts and structures, determine the shape of each cross section of the pyramid below. In the text, they kind of just gave you the like the picture, and it was kind of like, well, so I just kind of found another picture and thought maybe I'd try to draw it in a way. So if I had a horizontal cut, so if I imagine a plane slicing horizontally through your pyramid, what would the shape be? Now, the bottom of this pyramid, if you can't see it really well, is a square. And my hope is that you would realize that we would get exactly that. We would get a square shape over here, right? So you get a square. And then an angled cut. So if we were to come in and cut it in a way that it was not quite parallel to the not to the to the base. So let's say we had a thing doing something like this, and then so our plane is doing that. Let's kind of give it a three-dimensional vibe. And then what you'd have, hopefully you'd see it, is an intersection that's doing that on the other side, and you'd have more of a rectangle, or depending on, yeah, I think a rectangle, but to be safe, I might say a parallelogram. And then the next one we have is a straight up vertical cut. So if I were to slice it vertically, I guess it depends on where, because if I sliced it through this point, we would get a triangle, right? So, but if I were to slice it vertically, what am I going to get there? I know this was a terrible let me try again. I don't know, maybe this is better if you consider the vertical slicing, but what I'm noticing is that um, I would get, the intersection would be, it would slice down right here, and then it would cut it all the way down, and it would be a little bit wider here, and then I'd have something like this. So for me, that looks like a trapezoid. And really, that's it. Part of it is just to get us to visualize different situations. So I hope this video wasn't too terrible. But those are the only questions that we're gonna, or the only type of questions we'll look at in your exercises today. And let's talk about them later. Let me know if there's something I could do to do better. All right, take care, guys. Bye-bye.